Welcome to IND4 VET course, Cloud Computing. I'm excited to have you in the class. If you have questions about course content, please post them in the forums. Good luck as you get started, and I hope you enjoy the course. In this module, we'll discuss what the cloud is, what it supports, and how it is delivered. We'll also explore types of cloud services, type of cloud deployment, hosting technologies, as well as cloud platform service providers. Simply put, cloud computing is the delivery of computing services, servers, storage, databases, networking, software, analytics, and more over the internet, the cloud. Companies offering these computing services are called cloud providers and typically charge for cloud computing services based on usage, similarly to how you are billed for water or electricity at home. You are probably using cloud computing right now, even if you don't realize it. If you use an online service to send email, edit documents, watch movies or TV, listen to music, play games, or store pictures and other files, it is likely that cloud computing is making it all possible behind the scenes. The first cloud computing services are barely a decade old, but already a variety of organizations, from tiny startups to global corporations, government agencies to nonprofits, are embracing the technology for all sorts of reasons. Here are a few of the things you can do with the cloud, which are: create new apps and services, store, backup, and recover data, host websites and blogs, stream audio and video, deliver software on demand, analyze data for patterns and make predictions. Cloud computing is a big shift from the traditional way businesses think about IT resources. What is it about cloud computing? Why is cloud computing so popular? Here are 6 common reasons organizations are turning to cloud computing services. Cost, speed, global scale, productivity, performance, reliability. Cloud computing eliminates the capital expense of buying hardware and software and setting up and running on-site data centers, the racks of servers, the round-the-clock electricity for power and cooling, the IT experts for managing the infrastructure. It adds up fast. Most cloud computing services are provided self-service and on demand, so even vast amounts of computing resources can be provisioned in minutes, typically with just a few mouse clicks, giving businesses a lot of flexibility and taking the pressure off capacity planning. The benefits of cloud computing services include the ability to scale elastically. In cloud speak, that means delivering the right amount of IT resources, for example, computing power, storage, bandwidth, right when it's needed and from the right geographic location. On-site data centers typically require a lot of racking and stacking, hardware setup, software patching, and other time-consuming IT management chores. Cloud computing removes the need for many of these tasks, so IT teams can spend time on achieving more important business goals. The biggest cloud computing services run on a worldwide network of secure data centers, which are regularly upgraded to the latest generation of fast and efficient computing hardware. This offers several benefits over a single corporate data center, including reduced network latency for applications and greater economies of scale. Cloud computing makes data backup, disaster recovery, and business continuity easier and less expensive, because data can be mirrored at multiple redundant sites on the cloud provider's network. In this module, we will explore the levels of managed service, including infrastructure as a service, platform as a service, and software as a service. Most cloud computing services fall into three broad categories: infrastructure as a service, IaaS, platform as a service, PaaS, and software as a service, SaaS. These are sometimes called the cloud computing stack because they build on top of one another. Knowing what they are and how they are different makes it easier to accomplish your business goals. Infrastructure as a service, IaaS, is the most basic category of cloud computing services. With IaaS, you rent IT infrastructure, servers and virtual machines, VMs, storage, networks, operating systems, from a cloud provider on a pay-as-you-go basis. Platform as a Service, PaaS, refers to cloud computing services that supply an on-demand environment for developing, testing, delivering, and managing software applications. PaaS is designed to make it easier for developers to quickly create web or mobile apps, without worrying about setting up or managing the underlying infrastructure of servers, storage, network, and databases needed for development. Software as a Service, SaaS, is a method for delivering software applications over the Internet, on demand, and typically on a subscription basis. With SaaS, cloud providers host and manage the software application and underlying infrastructure and handle any maintenance, like software upgrades and security patching. Users connect to the application over the Internet, usually with a web browser on their phone, tablet, or PC. For example, services that are under IaaS categories are server and storage, networking firewalls/security, data center physical plant/building. Services lies under PaaS such as operating systems, development tools, database management, business analytics. Finally, SaaS services are the hosted applications/apps such as Gmail, Dropbox, Facebook, and many more. In this module, we'll discuss different deployment models of cloud computing. We'll explore private and public deployment models, hybrid cloud, HPC cloud, and big data cloud. Public clouds are owned and operated by a third-party cloud service provider, which deliver their computing resources like servers and storage over the Internet. Microsoft Azure is an example of a public cloud. With a public cloud, all hardware, software, and other supporting infrastructure is owned and managed by the cloud provider. You access these services and manage your account using a web browser. A private cloud refers to cloud computing resources used exclusively by a single business or organization. A private cloud can be physically located on the company's on-site data center. Some companies also pay third-party service providers to host their private cloud. A private cloud is one in which the services and infrastructure are maintained on a private network. Hybrid clouds combine public and private clouds, bound together by technology that allows data and applications to be shared between them. By allowing data and applications to move between private and public clouds, hybrid cloud gives businesses greater flexibility and more deployment options. High-performance computing, HPC, has become a popular offering of cloud computing providers. HPC is actually an architecture of arrayed computers or processors. The architecture runs together in a cluster. A cluster is a group of computers acting as one. HPC uses parallel processing as a strategy. HPC architecture can run quadrillions of calculations per second. A typical computer can run about 3 billion calculations per second. There are three components of HPC: computing, data storage, and networking. The cloud's flexibility, or elasticity, supports quickly building a cluster and dynamically adding to it if needed. Cloud computing provides an ideal model for HPC. As discussed, earlier, cloud can also provide the network and storage. Big data is term for a family of strategies to analyze, extract information, or trends from large, complex data sets. This kind of data analytics requires large amounts of data storage and high-performance processing. The cloud can deliver a solution to store and analyze big data sets. Cloud Cluster can be dynamically implemented to efficiently process the big data sets. Cloud solutions can also scale up or down as needed to accommodate the needs of the data to be analyzed. The concept of a data warehouse was created primarily to shield users from the poor performance caused by analyzing data. Typically, the processing of data is scheduled to run off hours when users are not connected to the system. The processed data is then stored in the data warehouse for reporting. Cloud computing provides a great solution for data analytics. Again, cloud's flexibility delivers an efficient solution for data reporting. In this module, we'll take a look at different hosting scenarios including bare metal computing, VMs, Docker, Kubernetes, on-premises computing, and cloud computing. We will also discuss best practices and use cases for cloud computing. Bare metal is a hosting strategy where software products, including the operating system, are installed on the physical hardware. All software is installed on the native hardware or bare metal. A laptop's native hardware and software is a good example. Most mobile devices operate this way. No virtualization is used. This is a time-tested, reliable strategy. There obviously are multiple fixed costs associated with this approach. The team must have hardware to which they grow into. However, today's hardware is so fast that it is highly likely that the hardware will be underutilized. Including virtualization allows the hardware to be more efficiently used and accessed by more users. Running virtual machines, VM, makes better use of the existing hardware. The hypervisor manages access to the physical hardware for each VM. This allows many instances of an operation system and software to run on the same bare metal hardware. As stated earlier, virtualization in cloud allows the enterprise to manage hardware like software. Administrators can make virtual templates of VM images. Multiple copies of the VM images can be made, each with their own IP address and host ID. Obviously, independent operating images will need a network. Virtualization in cloud provide virtual network adapters to allow VM to communicate identically to bare metal machines. VMs can provide stronger testing results as many copies of the live environment can be made for acceptance testing. Docker is a platform as a service, PaaS, product that provide virtualized operating system environments called containers. Docker containers are 100% independent from each other, and they are bundled with their own software libraries and other items. Docker container cannot run on their own. All Docker containers are run on a single operating system kernel called the Docker engine. The Docker containers are dependent on the single operating system kernel. The containers are much simpler than a full VM. Docker containers provide 100% predictability on how an application will be installed and how it will be executed. Once the Docker deployment pattern is established, it can be repeated and automated. Kubernetes is a platform as a service, PaaS, container orchestration product. Kubernetes can also be offered as infrastructure as a service, IaaS. Kubernetes automates application deployment, scaling, and maintenance. Kubernetes supports Docker containers and is more complex than the Docker. Kubernetes is built on layers, or blocks. These are referred to as primitives. The blocks are built up as the application scale up. The Kubernetes architecture is based on a structure called a pod. Pods house containers like Docker. Pods make up Kubernetes cluster. A pod is independent and has its own IP address. A Kubernetes service is a set of that works together within the Kubernetes cluster. The concept of on-premises computing, on-prem, is the traditional computing model where all hardware is controlled by the firm. The computing services are delivered on the firm's network. Traditional on-premises computing requires large amount of upfront effort and investment. Often the hardware must be installed with excess capacity. Excess capacity is very inefficient. Cloud services can be delivered on-premises. With on-premises computing, the firm manages hypervisor and cloud services delivered only on the firm's network. As stated earlier, on-premises computing enables the firm to control its data. Cloud services can be as simple as software product remote hosting services. This service involves one of the options of cloud computing making use of virtualization. The cloud options can be either private, public, or hybrid. In either case, the cloud uses one or more virtual machines to execute the software product. Delivery of the software services is delivered either by a public, private, or virtual private network. Edge computing is where computing services, including processing and storage, are brought physically closer to customer. Edge computing origins come from content delivery of large data files, including audio and video. The delivery of this type of data needed to be close to users as it was subject to latency. As edge technology advanced, it has moved into running software and application, keeping latency low. Edge computing is popular in gaming and Internet of Things, IoT, as responsiveness is critical. Understand the trade-offs of cloud computing and what you can tolerate. Avoid upfront costs. Have a sensitive data strategy. Understand the risks if data is hosted by the cloud provider. Start small and build a minimal viable cloud solution. Know where the opportunities are to use cloud to reduce costs. Often infrastructure as a service, IaaS, and software as a service, SaaS, has the largest impact with productivity and costs. Use metrics and telemetry to exactly understand the value cloud is delivering. As cloud matures, more and more use cases are applicable. However, there are some key use cases that are relevant for almost all users. Software hosting and software as a service. On-demand expertise and support. Email hosting. Backup service and disk. Virtual desktops. Development and test environments. DevOps tools and process. In this module, we will compare some of the cloud platforms. We'll discuss Microsoft Azure, Amazon Web Services, Google Cloud Platform, and IBM Cloud. Today, the services from the popular cloud platform providers are very similar and interchangeable. Azure is the cloud offering from Microsoft. Azure went live in March of 2014. Azure features such services as virtual computing, mobile desktops, storage, backup, database, development, DevOps, blockchain, artificial intelligence, and more. Azure offers Linux computing as well as Windows operating systems, packages for different sized firms from small to enterprise. Azure offers a rich console for administrators to manage its services. Amazon Web Services is part e-commerce retailer of Amazon.com. AWS offers metered pay-as-you-go computing services, including virtual servers, APIs, storage, networking, database, DevOps, blockchain, artificial intelligence, and more. AWS went live around 2006. AWS Popular Elastic Cloud Computing, EC2, has been used by government, Netflix, Airbnb, and other popular applications. EC2 provides service including virtual desktops, clustering, networking. EC2 also enables teams to template running servers with a service called Amazon Machine Image, AMI. AMI allows team to copy and run templated images. AWS pricing is competitive and can fit any size shop. Administrator manage services using the AWS console. AWS offers varieties of IaaS, SaaS, PaaS, FaaS. The Google Cloud Platform, GCP, provides cloud services such as Infrastructure as a Service, IaaS, Platform as a Service, PaaS, and Function as a Service, FaaS, customers. Google lists over 100 products in their brand including application development, storage and database, networking, Internet of Things, IoT, artificial intelligence, data analytics, API. The IBM Smart Cloud, IBM Cloud, has had different manifestation over decades. Today's IBM Cloud emerged from several decades of central mainframe offerings. Today's IBM Cloud went live in 2010. The IBM Cloud offerings include IaaS, PaaS, private cloud, and virtual private and hybrid cloud. The IBM Cloud offers the typical virtualization services and also offers its products as solutions for DevOps. Data analytics are major offering of the IBM Cloud. The IBM Cloud makes use of open standard, including open source software as parts of its solutions. The IBM Cloud does not offer a single console, as its cloud offerings are so numerous.
Thank you. If you have questions about course content, please post them in the forums.